Okay, so you can definitely expect a problem like this where I'm asking you to find the basis for the null space and the basis for the column space for a given matrix. This is like the main thing from section 2.8 that you want to be able to do, and this is what we're talking about now. And it turns out the process is not something new and crazy. Remember, for a null space, we're trying to solve ax equal to 0, and we learned how to solve things like that before by making an augmented matrix. So we're going to go ahead and do that here. Equals 0. All right, this is our augmented matrix. And so once we have that, we're going to do our row operations, get it into reduced row echelon form. Again, you can use your calculator, or now that we're doing things online, you could use some sort of app on your phone or on the computer, whatever you need to do to get reduced row echelon form here. And it should look something like the follows, assuming that I typed everything in my calculator correctly here. And so remember that since we had a 3 by 4 matrix here, there are 4 variables, x, y, z, w. And if you look at this, we have 2 pivots here, which means that there are going to be 2 free variables. And in particular, that's going to be y and w are going to be free. And then what do? We write out our equations here. We'd say x minus 3y plus 1.5w equals 0. So we're writing our pivot variables in terms of our free variables. Our second equation is going to be z plus 1.25w equals 0. Then that means z is negative 1.5w. And once we've done this, then we can write our generic solutions x, y, z, w in the following way. X is 3y minus 1.5w. Y is y. Remember, we leave the free variables alone here. We're just changing our pivot variables in terms of the free variables. And then once you've done this, you break it apart into the y vector, which would be 3, 1, 0, 0, and the w vector, negative 1.5, 0, negative 1.25, 1. And then it turns out, once you've done this, you've actually done all the work. So then the basis for the null space is going to be exactly these 2 vectors that we just found. And furthermore, if you want to find the basis for the column space, you look at where did you have your pivots. My pivots was in column 1 and column 3. And you have to go back to the original matrix and take column 1 and column 3. And I want to point out, if you don't go back to the original, if you use the new reduced ones, you will get the wrong answer. But you just take those 2 original pivot columns, so negative 3, 2, 3, and negative 2, 4, negative 2, and that right there is actually going to be your basis for the column space. So I told you that the row operations and reduced row echelon form, solving this equation, it's all going to be the same thing over and over again. In this section, even though it's 2 completely new topics, null space and column space, we still use our row operations, we still use reduced row echelon form, and that will again give us the basis here. So this is what I'd be looking for in your final answer. We're going to do another example of this before we finish off this section.